What we are going to do now is to make an estimation of square root of 10, 13 and 15 using the number line. The first thing you have to recognize is that all three numbers 10, 13 and 15 lies between the perfect squares which are actually 9 and 16. So what the interval we want to consider is between 9 and 16. So in other words, square of 3 and square of 4. So first off, let's start with drawing the number line. So we start off with the number line. So let's draw a number line there. We start with the area here, which is 9, and down here is 3, right? And then what we do is let's number this up to 16. Okay, so let's say this is 10 here, 10, 4 squares, 10, 11, 12, 13, 14, 15, 16. So 16 comes here, and down the square root of the perfect square 16 is 4, and we obviously don't need this little part here, so we get rid of it. Okay, and let's complete numbering. So this should read 10, 11, 12, 13, 14, 15 and 16. The next thing you want to do is we want to divide this segment so that you can recognize we have 3.1, 3.2. In other words, decimal numbers approximated or rounded up to the nearest tenth can be seen in the number line. The first thing you need to know is you have to first identify the middle of 3 and 4, which happens to be this point here. So if this is 3 and this is 4 and the blue line here is exactly the middle of 3 and 4, this should be 3.5 right there. And you know that this is the middle because if you count the number of squares, you have 4, 8, 12, 13, 14 on this side, and on this side also you have 4, 8, 12, 13, 14. So 14 squares on this side, 14 squares on this side. So this point here is exactly the middle of 3 and 4. So the next step you want to do is you want to divide this segment from 3 to 3.5 to 5 equal parts. So this we do visually. We don't want to do it exactly, but we will do it visually, graphically, through trial and error. So here you go. So I would say I'm just estimating, so maybe this would work like that, right? So you can see that these are all of equal length, and how many segments you have? 1, 2, 3, 4, 5. So that this point is 3.1, 3.2, 3.3, 3.4, 3.5. You can see this is a bit larger than this, but doesn't matter. We are just estimating. So likewise you do the same thing onto this side. So we put how many dots? 4 dots equally spaced. So there go 1 2 3 4. Okay, so this point here is part of the number line right there. Okay, so these are points in the number line, so let's name them. Okay, so this would be 3.1 right there, this will be 3.2, this will be 3.3 elongated, and this will be 3.4, and this will be 3.6, 3.6, this will be 3.7, this will be 3.8, and this will be 3.9. So remember what we did first was to find the middle point, which is this one here, and then we use four divisions inside 3.5. Now you can clearly see or identify the square root of 10. Let's see where the square root of 10 falls. So you can see that 10 is right here, and on this side you have the square roots, you have the areas on this side, and you can see that 10 is nearer to 3.2 than 3.3, so it's nearer to, it's near this point there, so that you can say that square root of 10 is equal to 3.2, which is an estimate. Likewise you can, let's find where 13 comes. So 13 is here, and you can see 13 is near to 3.6 than 3.5, so we say square root of 13 is roughly equal to 3.6. Likewise, let's see what 15 belongs to. So let's see where 15 is. 15 is right here, and 15 is near to 3.9 than 3.8, so it goes right there. So we say square root of 15 is equal to 3.9. Now remember, all these are estimates, so this is an estimate, and so is this one.